Welcome student engineers. Today we are going to learn on forces and I'll elaborate few things concerning forces. So our topic today is forces. And in our class we are going to learn to define what a force is, and we'll give representation of a force. Representation of a force. We will do force systems and the law of forces. Law of forces. So let's define a force. Note that a force is a pull or a push. So when you pull or push an object in the direction of a force in a particular direction, whatever you are impacting on that force is what we term it as a force. Now, a force is a vector quantity. It is a vector quantity. What we mean by a vector quantity is that it has a magnitude, it has direction. So the two representation will show us that it is a vector quantity. For example, if you have a force, let's say of 20, or this is our force of 20 newtons. So this is what we term it as our magnitude, and the arrowhead is giving us the aspect of direction. So when you want to represent a force, so a force is represented by three things. Number one is the magnitude. Number two is the direction. That's why it has an arrowhead. And number three is a line of action. So in our previous example, this is the magnitude, the arrowhead to give us the direction, and the line of action. So that is simply representation of a force. Now let's go to force systems. So force system, when we say a force system is simply a collection of a number of forces. So if you have a forces more than 2 or 3 or 4 forces, we term them as a force system. So it's simply collection of a number of forces. Now we have 7 types of force systems that I'm going to discuss in detail, but the list is not exhaustive though. So a force system number 1 in our screen is a coplanar force system. A coplanar force system is a system whose all forces act in the same plane. So if this is our plane and we have a number of forces acting in that same plane, let's say this is our x and this and our y, and we have force 1, 2, 3, and 4 in that same plane. So this type of a system is what we call a coplanar force system. A non-coplanar force system is a system whose forces act in different planes. You can see that this is a box and we have a plane YZ, which is this plane. We have a plane XY along here, and this one being YZ on the top. So one force F1 on this plane, F2 on this plane, and F3 on the opposite plane. So in this type of collection, we term it as non-coplanar force system. A force system number 3 is collinear force system. Collinear from the word line. So in this type of system, we term it to be a system in which forces act along a same straight line. We have force 1, force 2, and force 3. So if we extend these forces, you'll find that all of them lie along the same line. We call it a collinear force system. Non-collinear force system is simply an opposite of collinear. So in noncollinear, saying that these are forces which are not acting along a straight line. You can see that the nose of this vector or the nose of this force is acting upwards, the other one is down, and force 2 is sideways. So you'll find that they are not simply in a straight line. We call it a noncollinear force system. Another type of a force system is concurrent force system. In this type of system, a force system, the forces are passing through a common point called a point of concurrency. So if you observe in my diagram, a point of concurrency is here. So if they are passing through the same point, we term that force system as concurrent force system. Parallel force system, when line of action of set of forces are parallel. When we were introducing forces, we said we represent a force with the line of action, a arrowhead to show the direction and the magnitude. Now, this is the arrowhead of the 4 forces here. So, if the set of forces cannot meet, or rather they are parallel, we give them as a parallel force system as that. Non-concurrent force system, forces in this system do not intersect each other at a common point of concurrency. So this is a kind of an opposite from the concurrent. Remember, for the concurrent we said they all intersect at the point of concurrency, but for non-concurrent they do not intersect, such that if we happen to extend these forces, they'll not meet at one particular point. We call them a non-concurrent force system. So students, I hope by now you can be able to list and explain with use of diagrams any types of a force system, or if you're given a force system to identify it, you can be in a position. The law of forces, parallelogram law. In parallelogram law, this is how it states that if two forces acting at a point are represented in magnitude and direction by an adjacent side of a parallelogram, then their resultant will be represented in both magnitude and direction by a diagonal of a parallelogram drawn from that point. I'm going to illustrate it. So in parallelogram law, if we have, let's say, a force system of this kind, let's say this is our point O, or rather the origin of our forces, and let this be our OAB, our force 1, and OB be our force 2. Now, to get the resultant using the parallelogram law, we are going to construct another force parallel to OB from point A, or rather the head of this vector force here. So we will have another force here, like that, parallel to OB. So OB with, let me call this point C. OB and AC would be parallel. And this line will as well be parallel to OA. That is from the nose of this vector to the nose of vector AC. So for the resultant, we'll have a resultant. Remember we said you'll have a resultant which is a line drawn diagonal here. A diagonal line here from point O. So this would be our R, or rather the resultant, using the parallelogram law. And our angle, or rather direction, will be indicated with this angle here. Let me call it theta 1. So you will measure this with the magnitude, or rather using the suitable scale that you used in drawing your two forces. Measure the angle with your protractor and you get the direction of that force. Now, for the resultant, what do we mean by resultant? Resultant is a resultant of a number of forces acting at a point is that single force which would have the same effect if it replaced by those forces. So, for example, in our R, if this is our resultant, this R would have the same effect if it's used to replace OA and OB. So magnitude of OA and OB, if they are equal in magnitude and direction, we will have our resultant R, which will simply balance all these forces and will have the same impact or effect that the two forces would have caused in that matter. Let's move on to triangular or triangle law of forces. Triangle law of forces. If three coplanar forces acting at a point are in equilibrium, they can be represented in magnitude and direction by the sides of a triangle taken in order. You can also give that law as if two forces acting at a point are represented in magnitude and direction by two adjacent sides of a triangle taken in order, then the closing side of a triangle taken in reversed order represents the resultant of forces in magnitude and direction. So let's say we have two forces from a point, let's say OA and B. Remember we said we are using arrows to indicate our forces. If these two forces are equal in magnitude and direction, and we want to use a triangle law to get its resultant. So we are going to construct a single force. Remember, we are saying that if we are constructing the two forces using a same scale, considering the scale simply due to their magnitude, and then you take it in order. That is, if let's say we have this diagram here, so we'll have this force B, and then at the nose of force B we will have another force of A. Now our resultant will be now the closing side of this triangle, such that we will have our R here. That will be our R, and it will now be in opposite direction. So you can observe that this one is in a form of a triangle. That is simply how a triangular law acts or is being illustrated. Get the magnitude of the two forces, get a suitable scale, draw it in order, that is, let's say from A, and then this is our A, and then B, the vector of force B and A in order, and then you have your resultant in magnitude and direction with a resultant that is opposite direction as that. So remember we said in triangular law, if two forces are represented in magnitude and direction by adjacent sides of a triangle, then its resultant will be represented in magnitude and direction by a force that is in the closing side of a triangle taken in order. So I have given a note that is to tell us what an equilibrium is. So when two or more forces act at a point are arranged to balance each other, the forces are said to be in equilibrium. So it is good to understand what we mean by equilibrium. Now, a law number 3 of forces is polygon law of forces. Now, in polygon law of forces, if more than two coplanar forces acting at a point are in equilibrium, they can be represented in magnitude and direction by sides of a polygon taken in order. The closing side of a polygon represents the resultant of the force system in magnitude and direction. Please consider the diagram here. I have a diagram with a number of forces. We have force 1, force 2, force 3, and force 4. So to get the resultant, so if you have such a force system and you want to get the resultant, remember we are finding the resultant using the polygon law. So in polygon law, you can name your diagram and have this with capital letters A, B, C, and D. Remember, I'm putting our letters in between a force. That is why I'm having A and B for force 1, B and C for F4, C and D for F3, and D and A for F2. So you will identify a suitable scale for this. Remember, this is our force diagram, and here is our angles given in degrees. So you can now proceed to do a force diagram, and remember, in your force diagram you'll have to identify a suitable scale due to a magnitude of the forces, magnitude, the angles will remain just like they are. Now, from here, you can now have a point and draw force F1 and have it as AB, because if you have indicated it as this, that will mean that our F1 will be represented by AB, our F4 will be represented by force BC, and it must be in order, just like they are. So when we say in order, it means that you'll have to construct a force parallel to the other one after drawing a corresponding force. For example, this is our AB for F1. Our next force would be BC for F4. So it would be in this direction. So this is our BC. Our next force would be F3 in this direction, a force parallel, and this would be represented by CD. The other one would now be F2, a force parallel to this one, F2, and this is represented by DA. Not DA because it's the closing side. So this is D and you can give a note. So our resultant now would be here. Our resultant will be indicated from the nose of this vector to where we drew our first force, like this, to the nose. So this is our R. And we will read the direction from the tail of the first force. So we are going to read our direction from here. You get the direction of the resultant force. So that's all on polygon law. Remember, we've said that in polygon law, if a number of coplanar forces equal in magnitude and direction, taken in order, then the closing side of the polygon represented in magnitude and direction will give us our resultant. Now, I'm going to define what an equilibrant is, because in a number of forces it's good to know what we mean by the word equilibrant. So an equilibrant is a single force which, if added to a system of forces acting at a point, it produces an equilibrium. That is, a force that will neutralize all other forces. That is what we term when we say an equilibrant. Thank you so much for watching, and we are much grateful for your support. Please keep on subscribing and supporting this channel. Thank you.